today we're going to keep talking about absolute value equations. We're going to do a few more examples together, a little more complex. We started pretty basic yesterday, and then you'll have some practice time. So let's look at that. The note, I already passed out the note outline. It's right over here if you want to come grab one. Okay. There we go. Again, all of our dates for this week's notes are off a day since I had already printed them before we pushed back one day. Here's the notes right behind you. Okay. And so we said yesterday that to solve an absolute value equation, we want to isolate the absolute value expression first. Okay, so we're going to continue doing that. We're going to isolate the absolute value expression on one side of the equation. Okay, so in this example 1, we've got to get rid of that 11. Okay, that 11's got to move to the other side. If you like to separate the left and right, go ahead and draw that line if it's helpful to you. So we're going to do opposite operation. So we're subtracting, and what you do to one side, you do to the other. So that's going to leave me with the absolute value of v minus 6 equals 11. We noted 3 different possibilities yesterday. I'm just going to rewrite them up here as a reminder. We said once you isolate, okay, so isolate the absolute value, then there will be, if it's equal to a negative, a 0, or a positive, those are 3 different possibilities. Okay, so if it's equal to a negative, that means no solution. You cannot get an output of a negative when you take the absolute value. If it was equal to a 0, yeah, let's just take this one. There you go. You're welcome. Okay, if it was equal to a 0, you can't, 0 has no sign. It's not positive or negative, so we're not going to be able to split it in our solving. So that means there's only going to be one solution. And if it's equal to a positive, that's when we knew there was going to be 2 solutions. Okay, so that's just a little reminder of what we talked about yesterday. So first we do the isolating, and then we'll know if there's going to be no solution, 1 solution, or 2 solutions. So here, once I've got it isolated, okay, am I equal to a positive, negative, or 0? Equal to a positive. So that means there's going to be 2 solutions here. So this is where I split. I take the inside of the absolute value, because what is on the inside here could be 11, it could be negative 11, because when we take the absolute value of either of those, we get 11. Okay, so I take the inside, whoops, switch back to my pen, and we set it equal to the 11, and we set it equal to the negative 11. Okay, the inside, the input there could be positive or negative. Now I solve each of those separately. Okay, again, if you need to split, you can split. Okay, your solving process is the same on both of these. In this case, we're moving the constant by adding. We're adding 6 to both sides. Okay, so over here, we get v equals 17. And over here, we get v equals negative 5. Okay, what did we do yesterday after we solved, after we thought we had our solutions? Was the next step. We checked. Okay, so I'm going to check that both of those work. Okay, so I'm going to have the original with a blank. Okay, I'm using parentheses there for what I'm going to plug in for V. Okay, so I'm going to first try the 17. So when I plug in 17, remember, order of operations, when you're doing absolute value, you do what's inside the absolute value first. Okay, it falls like with the P on PEMDAS, okay? You do what's inside the parentheses first, you do what's inside the absolute value first. Then you take the absolute value and then you do whatever's on the outside, okay? So inside the absolute value, we've got 17 minus 6, which is 11. Okay, and then we still have the absolute value. So the absolute value of 11 is 11. And we're then adding 11, which comes out to 22. That's what it was supposed to equal. That checks out. So now I'm going to see, does it check out? Does it work if I input our other solution, which we got to be -5. So if I plug in -5, do what's inside the absolute value first. So -5 and -6 is -11. The absolute value of -11 is 11. And then I'm adding 11. Again, I get 22, which was what I'm supposed to. So those both check out. So -5 is a solution and 17 is a solution. Now, obviously, there are quicker ways to, you don't have to check by hand. I do definitely want you to check, but you could type that in Desmos and see if it comes out to 22. You don't have to do step by step by hand, okay? So you can use Desmos to check your work as well. All right, let's take a look at the next one. Okay, again, our absolute value expression in the equation is not isolated. So first I have to get that by itself. So I'm going to move the 15 to the other side by opposite operation, which is subtraction here. So that isolates our absolute value expression of the absolute value of 3x minus 3, and it must equal 15. So is that a positive, a 0, or a negative that it's equal to? Now that I've isolated it. I got it by itself. Is it equal to a positive, negative, or 0? Somebody can tell me if that 15 is positive or negative, right? Positive, thank you. Okay, so that means we're going to have two solutions. So we're going to set the insides, that's 3x minus 3, equal to 15, but also equal to -15. Because what is inside could be positive, could be negative. So then we're going to solve each of those. So we're going to add the 3 over, isolate the variable term. So that leaves us with 3x equals 18 here, and 3x equals -12 here. Then we have to get rid of the 3 coefficient by dividing. That's the opposite operation in this case. So then I am left with x equals 6 and x equals -4. Okay, so this time I'm going to check in Desmos. Okay, so you can check by hand like I just showed you, or you can check in Desmos. All right, so my original equation, absolute values on this keyboard down here So I want the absolute value of 3x minus 3. Then outside of that, I had plus 15. Oops. Plus 15 equals, and I don't even have to put what it equals. So I can do it like this, and I can just replace x with those numbers, or I could make a table out of that. Okay, and I could check and see, and I could say, okay, what is it when x is 6? 30. Is 30 what it's supposed to equal there? Yeah. Okay, what about when x is negative 4? Also 30. So both of those, when I plug those in, they both come out to 30. Okay, so you can check it like that. Okay, it also graphed it for us. If you wanted to check it graphically, I guess you could. You could see, okay, when I go to negative 4, and you could scroll up and see, there it is. There's a point at negative 430. Okay, and you could scroll over to 6 when x is 6. Yep, 630. Okay, so you could graph it, you could use the table, or you could just plug and chug. And when I say plug and chug, I'd replace the x, I'd put parentheses 6. Too many parentheses there. Okay. And that should, oh, the x is still there. I was like, why isn't that telling me what it is? Okay, so I replace this x with a 6 and see it tells me 30. So lots of different ways in Desmos that you can check those answers if you don't want to check it by hand. Okay. Let's see. Go back to full screen here. I'm just going to put a note that I checked in Desmos. And both worked. So those are both solutions. All right. Just 2 on the back. These now to isolate. We've got 2 steps to isolate because our absolute value expression has a constant and a coefficient. So we've got to move 2 things before we're isolated. So first thing is to move the constant. So I'm going to subtract that 8 over. So then I'm left with 3 times the absolute value, W minus 6. And then 41 minus 8 would be 33. And I've got to get rid of the 3 coefficient that's being multiplied in front here. So I'm going to divide that over. So then I'm left with the absolute value of W minus 6 equals 11. So now I've isolated my absolute value. It's equal to a positive, so I know there's going to be 2 solutions. So I'm going to take the inside. And again, I'm going to take the inside and set it equal to positive 11 and negative 11. Now I'm going to solve both of those by isolating the W. So I would add 6 to both sides in both of these. So we end up with W equals 17. And W equals negative 5. Are those the same answers we got on one on the front? Oh yeah, huh. Interesting. All right, so then I'm going to check those in Desmos. Okay, so this time there's a 3 on the outside. And inside is, and now I'm using X, not W, when I'm in Desmos. And then on the outside, there's a plus 8. Okay, so again, I can quickly make a table of that and just type in what I want to plug in. Let's check 17. It comes out to 41. Is 41 what it was supposed to come out to? Yeah, right? So 17 worked. Okay, what if I plugged in a negative 5? Also comes out to 41. So both of those check out. So both of those are solutions. Okay, and again, I'll just make a note that I checked in Desmos. All right, last but not least, let's try isolating the variable, or excuse me, the absolute value expression for this piece right here. So I'm going to add the 43, which is the constant, to the other side, which is going to leave me with 4 times the absolute value of y plus 6, 52. Okay, then I've got my coefficient I need to get rid of, and that is going to be by dividing by 4. We do to one side, we do to the other. So I'm left with the absolute value of y plus 6 equals 13. Now, again, a positive. So none of them on this page today had those special cases we talked about yesterday, because now that I've isolated the absolute value, it's still equal to a positive. So I'm going to split it and set the inside equal to 13 and the inside equal to negative 13. And I'm going to solve each of those separately. Okay, but it's the same step in both. It's subtracting the 6 over. So I end up with y equals 7 and y equals negative 19. So I'm going to do a quick Desmos check again. So this time, get rid of that table, change my equation here. So it is 4 times the absolute value of x plus 6. And then it's a minus 43 on the outside. Okay, and when we plug these in, we want them to come out to 9. 9 is what our equation is set equal to. Okay, so if I plug in a 7, comes out to 9. Good, good. And if I plug in a negative 19, also comes out to 9. Very good. So those both check out. Well, both of those are solutions that we checked in Desmos. Y'all feel okay about this? Now, can I show you something else in Desmos? None of these were set equal to 0, right? If I set them equal to 0, meaning I moved this constant on the right, instead of isolating the absolute value, what if I got everything on the same side so that it was set equal to 0? I'm going to show you what happens in Desmos when you do that. So here we go. So I'm going to try to get everything to one side. Right now, this is equal to 9, right? If I move the 9 to the left side, how would I move it? How would I need to get that 9 to the left side? I would have to subtract it, okay? So if I did negative 43 minus 9, I would have negative 52. Okay, so let me change this to minus 52 over here. Okay, so now when I look at this graph, this is set equal to 0. Do y'all agree? I got it equal to 0. So when that's the case, when your equation is set equal to 0, you're looking for the zeros. Zeros is another word for x-intercepts. Do y'all remember that? The zeros or x-intercepts or solutions of a function is where it crosses the x-axis. So I could come down here and see it crosses the x-axis at negative 19 and it's 7. Those are the two solutions we got algebraically, aren't they? So if you, instead of so algebraically, how you solve this is isolate and split and solve like this. Graphically, what you would do is get it set equal to 0 and look for the x-intercepts. Okay, so if you prefer to do this graphically, you could. So one more, just to show you that it works all the time. So I've got 3, and then that was x minus 6. And then what would this become over here? It was a plus 8 equals 41. If I moved the 41 to the other side, how would I move it? I would minus. So that's a positive 8, and I would subtract 41. That would end up being minus 33. You don't actually even have to do the math. You could write plus 8 and then minus 41. You don't even have to combine them. If you're afraid you'll make a mistake, just write it and then move that constant over with the opposite operation. Okay, and let's look at our x-intercepts here. -5 and 17. Is that what we got algebraically? Okay, so there's a little graphing way to solve, okay, in Desmos. Okay, because when you're finding a solution, you remember that term solutions, if you're solving when it's set equal to 0, you get everything to one side. This works with any function. We're going to do it with quadratics next unit. Okay, but if you get it set equal to 0 and graph it, okay, then you're finding the zeros or x-intercepts. Because technically what we're doing is we're getting it set equal to 0. That 0 is in place of y. Okay, so we're saying when y is 0, you're on the x-axis, right? So it's your x-intercept that you're finding. So just a little optional way to check your work or to solve. Any questions about this? Okay, if you didn't get that written down, that little reminder from yesterday, once you isolate the absolute value, if it's equal to a -0 or positive, that tells you how many solutions you're going to have. Okay, and if it's no solution, don't even bother trying. Just say no solution. You don't have to do any work to prove that. All right, so y'all got the rest of the class to practice. Okay, here's the calendar again, just to remind you. That test is coming up next Thursday. Now, we don't have a review day until Wednesday, but I'll tell you, I'm going to open the review today. Okay, so yes, you have Delta Math to practice, but if you finish it, if you're all caught up and you finish today's practice quickly, or you have some time this weekend, you can start the review. I think maybe some of you realized with this last test, some of you that didn't do the review, you came and took the test and were like, oh crap, I don't know what this formatting wants. Or we had the blanks for you to fill in and stuff because you didn't look at the review. The review was the exact same format as the test. The questions were very similar, okay? But if you didn't bother to do the review, you weren't really prepared. Okay, so I'm opening up the review. You have all weekend, Monday, Tuesday, Wednesday, so almost a full week to do the review before the test. So you can work on it, submit it, see what you missed. I'm happy to reopen it. I reopened the Unit 2 review last weekend before the test. So you could try again and get a higher grade. So if you try the review early and you get a bunch of stuff wrong, that's okay. That's a learning opportunity. You tried it. Now you know what you need help on and what questions to ask. You can ask them, okay? And I'll reopen it for you. You can redo them and get a higher grade on the review, and you're better prepared for the test. Okay, so take advantage of the fact that the review is open early and that it will automatically grade it when you're done and tell you what you missed so you know what questions you need help with. Okay, when RTI Scheduler opens today for you to self-enroll for next week's CAT tracks, I highly recommend you sign up for Tuesday and Wednesday, or one of the others, to ask some of those questions. I mean, we have a review day Wednesday. Of course, you can ask questions in class then, and it's just a practice day on Tuesday, so you'll have a chance for questions then. But if you feel like you really need more than that, sign up for CAT tracks one of these days. Or if you realized you bombed the Unit 2 test, okay, and you need to come and work on corrections or possibly do a retake, sign up for Cat Tracks, come and get that done before the 9 weeks test, because that Unit 2 material will be on the 9 weeks test. Okay, it's going to have Unit 1, 2, and 3. Okay, so make sure that you get signed up in Cat Tracks for these 2 days so that you can work on test corrections or just ask questions. If you know that you're going to want to retake that Unit 2 test, I would sign up for 2 days of Cat Tracks next week. I would sign up for one, either Tuesday or Wednesday, to come and work on corrections. And then I would sign up for another one. It could be Thursday. It doesn't have to be before the 9 weeks test, to do the retake. Okay. And actually, I don't think in RTI it'll let you sign up for Thursday because it's the math priority day. I think it's closed. It's only for me to draft. So if you want me to draft you on that Thursday to retest, okay, sign up on the pink paper up there on the front of under those hanging folders, that bright pink paper. If you sign up, put your name on there today, and I'll draft you for Thursday. As long as somebody else hasn't already. Yes. Yeah, go ahead. Any questions about any of the calendar or anything?